So the next section we're going to be looking at are quadric surfaces, and our objectives are to identify a cylinder as a type of three-dimensional surface, recognize ellipsoids, paraboloids, hyperboloids, and use traces to draw the intersection of quadric surfaces with coordinate planes. So a quadric surface is given by this formula. So these are the most general formula is ax squared plus by squared plus cz squared plus dxy plus exz plus fyz plus hx. I'm sorry, I'm missing a g. ef. My book doesn't have a g. hx plus iy plus jz plus k is equal to 0. Okay, and so for different values of these, we will have different types of quadric surfaces. So the quadric surfaces that we are going to look at, the first one is, we have the ellipsoid. Then we have the hyperboloid of one sheet. We have the hyperboloid of two sheets. We have the quadric cone. We have the elliptic paraboloid. The hyperbolic paraboloid. The parabolic cylinder. The elliptic cylinder. And the hyperbolic cylinder. Okay. All right, so let's see. The ways of trying to figure out what it is to take and try to reduce whatever this three-dimensional figure is down to down to a plane in each direction, and then put the whole thing back together. Okay, so the first one I'm going to do is the ellipsoid. Okay, so the ellipsoid looks like x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. All right, so this is this ellipsoid. We kind of know, we all know what an ellipse looks like. The question is, what does the ellipsoid look like? So in order to figure out what an ellipsoid looks like, I want to look at what it's doing in 3 different planes. So the first thing I want to do is say, let's let z equal to 0. So when z is equal to 0, that is the xy plane. And in the xy plane, I get x squared over a squared plus y squared over b squared is equal to 1. And this is an ellipse. So in the xy plane, I have something I'm trying to figure out why my system is not working like it's supposed to. There we go. Okay, so in the XY plane, we know that we can find our vertices. These are at plus or minus A, so this is A and negative A. And then our second vertice are B's. So this is B and negative B. And then I can put this together and draw my ellipse. So that's what I have in the XY plane, is this ellipse that looks like this. Okay. Second way I want to look at this now is I want to let let's let y equal to 0. So now we're in the XZ plane. And that looks like x squared over a squared plus z squared over c squared is equal to 1. And this is also an ellipse. So now I want to, again, draw my picture. And I'm going to have my vertices. Again, this is A, negative A, and A. I should have been very clear up here. This is Y. This is X. So this one is Z. And this one is X. And I'm going to let this be a green dot. And so now I get this ellipse that looks like this. Okay. So then I have one more. And now I'm going to let X equal to 0. And this is the YZ plane. And this is y squared over b squared plus z squared over c squared is 1. And this is also an ellipse. And I will draw one last thing. And so this is Z, and this is Y. So the Z is here. Let's see, what did I do? 1, 2, 3, 4. 1, 2, 3, 4. So I did that far up and that far down in Z. But I think the Y, my B was only kind of like 3 units about. So my B was like about here and here. So now I get this. So that is my third ellipse. So now the goal is to put these things together. So I know what it looks like in the XY plane. I know what it looks like in the XZ plane. I know what it looks like in the YZ plane. So now when I put this whole thing together, definitely easier to do it this way. Okay. So for the Z, remember we went up 1, 2, 3, 4, and that was the green dot. Down 1, 2, 3, 4. Okay. And then in the Y, we were at the blue. So we were right here and we were right here. So this ellipse is the exact one we just did. So that is the one that is in the YZ plane. So that looks the same. But now we have to draw in the one from the XZ plane and the one from the X, from the the one from the XY plane. So the one from the XY plane would be here and here. So that looks like this. It's looking kind of like a football. I don't want it to be too much like a football. Okay, and then I have this one. So as you can see, it's an ellipsoid. So it's rounded. So it is this three-dimensional shape that is rounded like that. So that is an ellipsoid. Okay. If I wanted to see what it looked like for any other value of z, so if I sliced it at any other value of z, so it would also be ellipses of different, it would be also ellipses. So let me see if I can go to here. There we go. There's the ellipsoid. Okay, so this picture right here is my ellipsoid. Okay. Now, as it says, if A, B, and C equal the same number, then I get a sphere. Okay. Then my ellipsoid becomes a sphere. Okay, so that's the ellipsoid. All righty. Then our second thing is the hyperboloid of one sheet. And the hyperboloid of one sheet is of the form x squared over a squared plus y squared over b squared minus z squared over c squared, and that is 1. Okay, so if z is equal to 0, I get x squared over a squared plus y squared over b squared is equal to 1. Again, I get an ellipse. Okay. So let's see. Let's try to be strategic here. Let's call this figure 1. We will call this figure 2. Actually, we will call this figure 1A. Make my life even easier. Call this figure 1B. This got to be 1C. This has to be figure 1A. And then this has to be figure 1b. Okay. So therefore, I don't have to draw all these pictures all over again. If in the z equals 0 case, I'm going to get figure 1a again. Okay, so we get the same figure as figure 1a. Okay, so we get an ellipse. Okay, so we get ellipse on the ground. And then let's see what happens if we let y equal to 0. So when y is equal to 0, I get x squared over a squared minus z squared over c squared is equal to 1. And that is a hyperbola. Now, if you remember, we did these quickly. So we will do this hyperbola. So again, I'm going to go out the same distance for A. So here's A. And here's minus A. And then I'm going to go up B, which is 3 units. And down here. And then I'm going to draw a square or a rectangle. Okay. And then, if you remember, we drew our asymptotes like this. And then we drew another asymptote like this. Uh-oh, that one up there is pretty bad. Let's do this one again. This one is pretty bad. That's not going through the center. Oh, that's because well, what's the problem here? Oh, the problem is my square. That's the problem. No. Well, what is the problem? There we go. Much better. Okay. And so then our hyperbola looks like this. Okay. So this is so I get a hyperbola that looks like that. And then if z is in the last case, x is equal to 0, I get y squared over b squared minus z squared over c squared is equal to 1, and I get another hyperbola. Okay. So let's try to see. Um, okay. And so this one is, let's see, I think B was 3 units. So this is Z, this is Y. So my blue dot was here. And then now my square and my, what was the other color dot? What was the Z dot? It was green. Okay, same thing. Draw my, what do you call it? Asymptotes. That's much better this time. Draw my other asymptote. Get another hyperbola this time. Okay, so now we put it all together. Okay, so now if you remember in the XY plane, we got an ellipse. So the XY plane, we got an ellipse. So here's the x-axis. So we got something like this. And then on the Y, we got something like this. And so we got an ellipse that is awfully big. I need to make that smaller, but that's where I am right now. So we got this ellipse that looked like this. And then we got a hyperbola that came through here like this. And it came through here like this. And then we got the other part of the hyperbola coming through like this. And then this piece coming through like this. And in between, we have ellipses. So they're ellipses this way. Up, that's a little crooked. They should be a little bit more on the slanted side. So it should be something like that. So that is the hyperboloid of one sheet. And there it is. Of course, theirs is much cuter than mine, but that is the hyperboloid of one sheet. Okay, so the hyperboloid of one sheet gives you ellipses or circles going around, okay? If A and B are the same, then these will be circles. If not, then they'll be ellipses. And then you can see the hyperbolas. Now, as you can see, here is the hyperboloid of two sheets. And so let's draw that next, unless you have a question. Okay. So the way I remember this, the hyperboloid of one sheet has one negative term, and the hyperboloid of two sheets has two negative terms. Okay, so most people write it. Let me see how your book writes it, because I know there's a way I like to write it. They write it the way I like to write it. Good. Okay. So the hyperboloid of two sheets is z squared over c squared minus x squared over a squared minus y squared over b squared is equal to 1. Okay. So two sheets, two negatives. One sheet, one negative. Okay. So this time it is very clear that if we set z equal to 0, I get negative x squared over a squared minus y squared over b squared is equal to 1. And that is an empty set. There are no points that satisfy that, because x squared plus y squared will never equal -1. So that's an empty set. So there is no graph when z is equal to 0. In fact, x squared over a squared plus y squared over b squared is equal to z squared over c squared minus 1, implies there's no graph until z is greater than or equal to c. When z is equal to c, I get x squared over a squared plus y squared I think Zoom is giving me grief right now. Is equal to 0. So that's just the 0.000. Sorry, 0,0 or 0,0 minus c. So the absolute value of z is greater than c. Okay. All righty. So let's see what happens. So we already know when z is equal to 0, at the point 0, 0, C and 0, 0 minus C, I just get a point. Okay, so let's say the absolute value of Z is greater than C. So what does that mean? That means then X squared over A squared plus Y squared over B squared is equal to some number. It's equal to some number K that's greater than 1. So I get X squared over A squared. Let's write it K squared. X squared over AK squared plus Y squared over A over BK squared is equal to 1. So I get ellipsis. So I'm going to get ellipsis for all the Z's that are greater than C. So I now know what that looks like. So now let's look at the second case when Y is equal to 0. So when Y is equal to 0, I now get Z squared over C squared minus X squared over A squared is 1, and these are hyperbolas. And these hyperbolas look like this. So this is the Z x-axis, and these hyperbolas are floating in the air like this. Okay. And in the other case, when C, that is X is equal to 0, I get Z squared over C squared minus Y squared over B squared is equal to 1. And these also are hyperbolas. And they look similar to the other picture. They look like, so this is Y, and this is, no, it's not. That is Z, and this is Y. And so I get something else at the same height. So it also looks like this. It may be a little flatter, who knows, but they look like that. So when I put it all together, I get something that looks like this. So I'm going to get something that looks like this. Something that looks like this. Then something that looks like this. And something that looks like this. And then I still get the ellipses. And I still get the ellipses. And that is the hyperboloid of two sheets. Okay, so those are the first three. Let's go on to number 4. It is not difficult. Number 4 is actually rather easy. X squared, so this is the cone, the quadric cone. and it is x squared over a squared plus y squared over b squared is equal to z squared. So first case, again, z is equal to 0. I get x squared over a squared plus y squared over b squared is equal to 0. So that's just the point 0, 0, 0. Oh, let me go back to this one real quick. This is the point 0, 0, C, and this is the point 0, 0, minus C. Okay. So I know that this quadric cone goes through the origin. And so now what happens if z is not equal to 0? So if z is not equal to 0, say z is equal to some number z naught, then I get x squared over a squared. Actually, let's say z is equal to k. I like that better. Then I get x squared over a squared plus y squared over b squared is equal to k squared. So again, I get x squared over ak squared plus y squared over bk squared is equal to 1. So I get ellipsis. Okay. So for any z not equal to 0, I get ellipsis. But now, if x is equal to 0, oh, we do y is equal to 0 next. If y is equal to 0, then I get x squared over a squared is equal to z squared, and that says z is equal to plus or minus x over a, and these are lines. So that's pretty easy to draw. So these are lines. Z is equal to x over a, and then z is equal to minus x over a. Z and x. And C, if x is equal to 0, I get y squared over b squared is equal to z squared. So z is equal to plus or minus y over b. And these are also lines. So I'm going to get so z, y, z is equal to minus y over b, positive y over b, and then z is equal to negative y over b. And so when we put it all together, I get, these are the blue lines for the z with the y-axis. So this is the blue line for the Z with the y-axis. Then I get the red lines for the Z with the x-axis, which kind of looks more like this. And then I get ellipses. And that is the quadric cone. Okay, so now what I need you to do, we still have 5 more in there. Actually, one of them is really hard. 3 of them, the other ones are easy. The most difficult one is the next one, which is hyperbolic paraboloid. So I need you to please review this so we can get through this quickly.
Okay.
Okay. This is, now this one is the one that's hard. Okay. And I'm probably going to grab the picture from the book because it's hard to draw. Okay. We're good. I'll
Okay, see you tomorrow.
Okay. All right. Bye. Samuel, I'm exhausted. I'm tired. Okay, son. I'll see you tomorrow.
See you tomorrow, Mom.
Okay.
Thank
Bye.
you.